Good morning, students. We are going to discuss about the most important question in the first unit, transmission line theory, and the question is the transmission line equation general solution or general solution of a transmission line. It is a very important question, and this question has been repeatedly asked in your university examination. Not only in exam point of view, to understand the upcoming lessons, especially unit 2, unit 3 and unit 4, this particular question is a very basic thing. So we can discuss about this particular question and answer in this class. The question is like this: explain in detail about the transmission line equation general solution, or obtain the expression for the current and voltage at any point along a line with is terminated in z0, and it can be asked in any different type of waves. The simple thing is, it is nothing but the general solution of the transmission line equation. Now we can go for the answer for this question. So we all know that the transmission line is a conductive method of guiding electrical energy from one place to another. Okay, so by using a transmission line, you can able to transmit an electrical energy from one point to the another point, and a uniform transmission line can be considered to be made up of infinite number of T section, each of infinitesimal size dx. So a complete transmission line will be made up of infinite number of T section. So this is a T section, and the transmission line, which is considered to be infinite, will be having several these type of T section, and the length of those T section is denoted as either ds or dx. So we can either denote that particular length of a T section to be dx or ds. So this is the transmission line. We are considering only one T section here, but an infinite transmission line consists of several other T section, and each of the T section length will be dx. The parameters, especially resistance, inductance, capacitance, are distributed over the transmission line. That is, R, C, G, L are being distributed in this transmission line, and the parameters R, L, G, C are considered to be the primary constant, from which we can able to derive the secondary constant. So this is the long line with elements of one of the infinitesimal section. So this is one of the infinitesimal section. So the voltage drop at the length ds is calculated as dE, and it is equal to Iz into ds. So this is very important. The voltage drop across the line ds, especially this particular line ds, is considered to be dE, and dE is equal to Iz into ds. Iz is nothing but the current, and dE by ds is equal to Iz. So this is the most important equation. So equation 1, we have to mark it as an equation 1. So equation 1 is dE by ds is equal to Iz, where dE is the voltage drop across the transmission line, this particular transmission line, and the current Di flow across this particular line. So the current Di which is flowing in this line, you can see the Di mark here, and it can be calculated as Di is equal to Ey ds. Okay, so Di is equal to Ey ds, and Di by ds is equal to Ey. Okay, so first we have calculated Di by ds is equal to Iz, and now we have calculated Di by ds is equal to Ey. Okay, so we have calculated the two parameters now, that is Iz and Ey. So now we have to differentiate the equation 1 with respect to s. Okay, so we have to differentiate the equation 1 with respect to s. So what happens is d square E by ds square is equal to, okay, d square E by ds square is equal to z into di by ds. Okay, d square I by ds square is equal to z into di by ds, and we know that di by ds is equal to Ey. So substitute here, you will be getting d square E by ds square is equal to z Ey. Okay, we are differentiating the equation 1 with respect to s. So d square E by ds square is equal to z into di by ds, and for di by ds substitute the value Ey. So you will be getting d square E by ds square is equal to z Ey. So that will be the equation 3. Similarly, you have to differentiate equation 2 with respect to s. So what happens is equation 2 is t square I by ds square, which is equal to y into dE by ds. So again, instead of dE by ds, you have to substitute the value of iz here from the equation 1. So what happens? D square I by ds square is equal to yiz, and instead of dE by ds, we have substituted the value iz. So now we got another two equation, that is d square E by ds square is equal to zey, third equation, and d square I by ds square is equal to yiz, and this is nothing but the fourth equation. Now you can see equation 3 and 4. Equation 3 and 4 are second order differential equation because it has d square. So it will be considered as the second order differential equation. To find out the solution for the second order differential equation, we have to consider d by ds is equal to m. Okay, to find out the solution for the equation 3 and 4, we have to consider d by ds is equal to m. So when d by ds is equal to m, what happens? We'll be getting m square e is equal to zey, and m square I is equal to ziy. Okay, so we are replacing di by ds by m. So what we get? The equation 3 will become m square e is equal to zey. Okay, equation 3, this is the equation 3. So m square into e is equal to zey, and when you solve this equation, you will be getting m square minus zey is equal to 0, and when you take commonly e outside, you will be getting m square minus zy into e is equal to 0, and when we calculate m square is equal to zy, m is equal to plus or minus zy, plus or minus root zy. Similarly, considering the equation 4, replace di by ds is equal to m, so that you will be getting m square I is equal to ziy. So when you bring all the constant on one side, you will be getting m square I minus ziy is equal to 0, and when you take I outside, so m square minus zy of I is equal to 0, and m square is equal to zy, and m is equal to plus or minus root zy. Okay, so by using this equations m is equal to plus or minus root zy, we can able to find out the solution of differential equation as e is equal to a e root of zys plus b e root of zys, and I is equal to c e root of zys, and d e root of zys. So this is a very important equation, my dear students. Equation 5 and 6 are very important equations. So these equations are the solutions for the differential equations, which is nothing but the equation number 3 and 4. So we have found out the two solutions, e and I. So e is equal to a into e root of zys plus b into e power minus root of zys. Similarly, I is equal to c e power root of zys plus d e power minus root of zys. Okay, so this is the equation which we have to remember forever, because this is the major solution for the differential equation, and from this equation only we are going to solve the further problems. So here a, b, c and d are considered as the arbitrary constants of the integration. Okay, so a, b, c and d are considered as the arbitrary constants, and we can see what is meant by arbitrary constants in the next video. The distance which is measured from the receiving end of the line will be calculated as s. So at the receiving end, we have to consider s is equal to 0, I is equal to IR, and E is equal to ER. So we are measuring the distance from the receiving end. Okay, so we are calculating the distance especially from the receiving end. So we have to consider I is equal to IR and E is equal to ER. In this equation, we have to substitute s is equal to 0, and we have to consider s is equal to 0. So what happens? ER is equal to A plus B and IR is equal to C plus D. Okay, so you are substituting s is equal to 0 in the equation 5 and 6, and we are considering E is equal to ER and I is equal to IR in the equation 5 and 6. So what happens? ER is equal to A plus B and IR is equal to C plus D. So we got another set of equations, and those equations are named as 7 and 8. Okay, so now what we have to do? We have to differentiate the equation 5 with respect to s. Okay, now we have to differentiate the equation 5 with respect to s. So what happens? See, dE by ds is equal to, when you differentiate with respect to s, you will be getting a into root zy e power root zys plus b into minus root zy into e power minus root zys. Similarly, the next equation also you'll be getting the same thing. De by ds is equal to a root zy e power minus root zys, and when you bring the minus here, you'll be getting minus b into root of zy e power minus root zys. Okay, so this is the equation number 9. Okay, so this is the equation number 9. And you know that de by dz is de by ds is equal to iz. So substitute that de by ds is equal to iz, so which we have been calculated from the previous equations. So de by ds is equal to iz. When you substitute that, you'll be getting iz is equal to a into root of zy e power root zys minus b into root of zy e power minus root zys. So I is equal to a into root of y by z. You are bringing this z here, e power zys minus b into root of y by z e power minus root zys. Okay, so we are differentiating the equation 5 and 6 with respect to s. So first we are going to differentiate the equation 5 with respect to s, and next we are going to differentiate the equation 6 with respect to s. So when we differentiate equation number 5 with respect to s, we will be getting I is equal to a into root of y by z e power root z by s minus b into root of y by z e power minus root z by s. Just you can go through these equations. Just you can look over these equations, especially the equation 9 up to equation number 9. So consider the equation I is equal to a into root of y by z e power root zys minus b into root of y by z e power minus root zys. Substitute s is equal to 0 and I is equal to ir in the above equation, so that you get ir is equal to a into root of y by z minus b into root of y by z. So this will be your equation 10, and you'll be getting, when you multiply the equation 7 with this equation, you'll be getting root of y by z into er root of y by z is equal to a into root of y by z plus b into root of y by z. That is, when you multiply ir by z, you'll be getting er into root of y by z is equal to a into root of y by z plus b into root of y by z. Okay, so this will be your equation 11 here. When we solve the equation 10 and 11, we can able to find out the answer for a and b. So we can find out the answer for a and b such that ir is equal to er into root of y by z, which can be written as 2a into root of y by z. So you'll be getting a is equal to er root of y by z by 2 into root of y by z plus ir divided by 2 into root of y by z. So when you calculate a is equal to, you'll be getting er by 2 plus ir by 2 into root of z by y by simplifying the above equation. And finally you get a is equal to er by 2 plus ir by 2 into z naught, because the value for z naught is equal to root z by y. So root z by y can be replaced by z naught, and z naught is nothing but the characteristic impedance, which we have discussed already in the previous class. So IR is equal to ER by ZR. So you'll be getting A is equal to ER by 2 plus ER Z0 by 2ZR. So by substituting this equation, IR is equal to ER by ZR, you will be getting A is equal to ER by 2 plus ER Z0 by 2ZR, and A can be calculated by taking ER by 2 outside. You will be getting 1 plus Z0 by ZR. So A is equal to ER by 2, 1 plus Z0 by ZR. In the exam point of view, you can write by solving 10 and 11, and you can straightly come to this particular answer. You need not want to write all these type of equations because it is time consuming and page consuming. Since this question will be asked for 13 or 15 marks, you cannot write whole thing. It may take up to some 10 pages, so it's not possible for you to write the other answer. So you can able to simplify this particular solution, and you can skip the answer and you can skip the derivations. You can come and write this particular answer. You can just write solving 10 and 11. We'll be getting A is equal to ER by 2, 1 plus Z0 by ZR. Similarly, to find B, B can be calculated as B is equal to ER by 2 into 1 minus Z0 by ZR. Because these derivations, especially for calculating 12 and 13, if you write all these derivation, and it will be time consuming, and there will be not enough pages will be provided. So you can straight away, you can write such that by solving the equation 10 and 11, we can able to find A and B such that A is equal to ER by 2, 1 plus Z0 by ZR, and similarly B is equal to ER by 2, 1 minus Z0 by ZR. So we have found out the A and B. Now we need to calculate C and D. To calculate C and D, what we have to do is we have to differentiate the equation 6. Okay, so we have differentiated the equation 5 here, and now we are going to differentiate this equation 6 as we differentiate equation 5. So in what is the procedure we followed for differentiating equation 5? The same procedure we need to follow for the equation 6 also. So differentiating equation 6 to S, you will be getting di by ds is equal to ey. So I am straightly coming away this answer because the method is same. So I am just finding out this answer, and you will be getting E is equal to c root of z by y e power minus root z by s minus d into root of z by y e power root z by s. So in this equation, substitute s is equal to 0 and e is equal to er. You will be getting er is equal to c into root zy minus d into root zy. And similarly, you can able to calculate IR into root z by y is equal to c into root z by y plus d into root z by y, and consider as equation 16. So equation 15 and 16 can be solved together, and we can able to calculate the value for C and D. Okay, so the procedure is same. What all are the procedure you follow for differentiating the equation 5? The same procedure you have to follow for the differentiating equation 6, and you may obtain the answer for such as equation 15 and 16. And now once you solve this equation 15 and 16, you may get C is equal to IR by 2, 1 plus ZR by Z0. And similarly, D is equal to IR by 2, 1 minus ZR by Z0. So you have calculated the arbitrary constant A, B, C and D. So A is calculated as A is equal to ER by 2, 1 plus Z0 by ZR. And similarly, B is equal to ER by 2, 1 minus Z0 by ZR. And C is equal to IR by 2, 1 plus ZR by Z0. And D is equal to IR by 2, 1 minus ZR by Z0. So remembering this A, B, C, D is very easy. For A and B, you have to remember, you have to place ER by 2 in before the braces, and you will be getting 1 plus Z0 by ZR and 1 minus Z0 by ZR. And for C and D, you have to keep IR by 2 in front of the braces, and you have to write 1 plus ZR by Z0 and 1 minus ZR by Z0. That's all. It's very easy. When you remember a single equation for A alone, you can able to write for B, C and D. So now what we have to do, we have calculated the equation for A, B, C and D. So substitute the value of A, B, C, D in equation 5. So when you substitute the value for A, B in equation 5, and you may able to solve those equations. So now substitute the value of A and B in equation 5. So what is equation 5? Once again, I'll just go to that particular equation 5. So equation 5, E is equal to A into root Z by S plus B into minus root Z by S. So substitute the value of A and B in equation 5 and C and D in the equation 6. So when you substitute that value, you will be getting A value is ER by 2, 1 plus Z0 by ZR e power root Z by S plus ER by 2, 1 minus Z0 by ZR e power minus root Z by S. So take the LCM such that ZR plus Z0 by ZR. So you will be getting ER by 2 ZR plus Z0 by ZR into e power root Z by S plus ZR minus Z0 by ZR e power minus root Z by S. So now which is common, you can see this ZR plus Z0 by ZR is common. So you can take this outside. So E is equal to ER by 2 ZR plus Z0 by ZR. If you take commonly outside, what you will be having? So you will be having ZR plus Z0 by ZR into e power root Z by S plus ZR minus Z0 divided by ZR plus Z0. Okay, ZR minus Z0 divided by ZR plus Z0 into e power minus root Z by S. And similarly, substitute C and D in equation 6. You will be getting I is equal to IR by 2, 1 plus ZR by Z0 e power root Z by S plus IR by 2 1 plus ZR by Z0 e power minus root, sorry, 1 minus ZR by Z0 e power minus root Z by S. So here plus it has been written, it must be minus, so please consider as minus. So IR by 2 1 minus ZR by Z0 into e power minus root Z by S. So again similarly IR by 2 1 plus ZR by Z0 e power root Z by S plus Z0 minus ZR by Z0 e power minus Z by S. Again you take the common factor outside and you will be finding out the answer. I is equal to IR by 2 Z0 plus Z0 by Z0 e power root Z by S plus Z0 minus ZR by Z0 plus ZR into e power minus root Z by S. So consider the equation 19 and 20. So 19 and 20 are the two important equations from which you are going to calculate the value of ER and sorry, we are going to calculate the values of E and I. So E is equal to ER by 2 ZR plus Z0 by ZR e power root Z by S, ZR minus Z0 plus ZR plus Z0 into e power minus Z by S, and I is equal to IR by 2 Z0 plus ZR by Z0 e power root Z by S plus Z0 minus ZR by Z0 plus ZR e power minus root Z by S. So this is the equation which has been repeated in the equation 21 and 22. So these equations are considered as the general solution for the transmission line. So the general solution for transmission line has been calculated as equation number 21 and 22. So which is nothing but the equation number 19 and 20 has been rewritten as equation number 21 and 22. So E and I has been calculated, that is the voltage and current has been calculated, and that is nothing but the general solution for the entire transmission line, where Z0 will be your characteristic impedance and ER will be the receiving end voltage, IR will be the receiving end current, and ZR will be the receiving impedance, and S will be the distance of the line. And for perfect matching, the value of Z0 and ZR must be equal, that is the characteristic impedance must match with the receiving impedance, so that only we can able to receive maximum number of signal. Otherwise there will be attenuation and we have to go for the alternative technique. So equation 21 and 22 are the general solution for the transmission line. So you have to remember, this is the final equation for general solution of transmission line. You can also represent this equation in another way. You can either do it in substitute A and B in 5 and C and D in 6 and you can find out. And another way of representing the equation 21 and 22 is given here. So E is equal to ER by 2. You can take ZR outside here. So 2 ZR plus Z0 e power root Z by S plus ZR minus Z0 e power minus root Z by S. When you take ER by 2 plus ER by Z0 by 2 ZR e power Z by S plus ER by 2 e power minus 2 Z by S minus ER by Z0 by 2 ZR e power minus root Z by S. So nothing but we are multiplying this ER by 2 ZR into inside the braces. So what happens when you multiply ER by 2 ZR inside the braces, you will be getting this equation, and when you take ER common outside, you will be having the equation of e power root Z by S plus e power minus root Z by S by 2, and when you take ER by Z0 by ZR, you will be getting e power minus root Z by S minus e power minus root Z by S by 2. So you know that this particular equation represents the cos h and this particular equation represents the sin h hyperbolic function, and E can be written as and it can be written as, and root zy can be represented as gamma, and gamma is nothing but the propagation constant. So E is equal to ER e power gamma S plus e power minus gamma S by 2, and ER Z0 by ZR is equal to, ER Z0 by ZR into e power gamma S minus e power gamma S by 2, and you have to consider ER by ZR is equal to IR. So ER is nothing but voltage and ZR is nothing but the impedance. So ER by ZR is nothing but the current. So you can rewrite the above equation. E is equal to ER cos h gamma S plus IR Z0 sin h gamma S. So it is necessary when you write up to equation 21 and 22. In some other thing, if may ask about the hyperbolic function, you can able to write this thing. Otherwise it will be very necessary if you stop at the equation 21 and 22. So you have calculated E value is equal to ER cos h gamma S plus IR Z0 sin h gamma S. Similarly, I value can be calculated as I is equal to IR cos h gamma S plus IR ER by Z0 sin h gamma S. So equation number 23 and 24 are rewritten as equation number 25 and 26. So with the equation 25 and 26, the general solution for transmission line is over. It is enough when you stop with the equation number 22 and 21 and 22. So it is enough when you write up to this particular 22, 21 and 22. The another way of representing equation, you may just go through, if suppose these things can be come in the problem. So for solving the problems, you may go through the equations 23 to 26. That is enough. So with this, the general solution for transmission line is over. I am once again repeating, this is a very important question, and this question has been repeatedly asked in the university examinations. So prepare well this particular question, and you can able to score more marks in the examination. Thank you.